So chapter 10D looks at probability. Now, before we sort of start looking at probability, I do want to revisit a couple of things we've done in the past, and a lot of it has to do with combinations involving restrictions. So for example, we look at, let's say we want to create some four-letter words. They won't really be words because it's just random arrangements of letters, but we're using arrangements of the letters special. And we want to see how many of these words are going to begin with a vowel. So we're not just looking at how many combinations or rearrangements there are of the word special. We have the restriction of it starting with a vowel. So the way I like to think of it is I'm going to draw 4 boxes because I know I've got 4 letters to choose from. And in the boxes, I'm going to write down the number of options I have for each letter. So I know the first letter needs to be a vowel. So in fact, there's only 3 vowels in the word special. So I have 3 options for my first letter. Now let's say I've already chosen one of these 3 vowels. Now my second, third, and fourth, they can be a vowel or any other random letter. So if I've already chosen one letter, I have 1, 2, 3, 4, 5. I've only got 5 letters left to choose from. For my second letter, I've got 5 options. Then I'll only have 4 options for my third letter and 3 options for my fourth letter. So we can use the multiplication rule here by just multiplying all the options we have all together. So first letter, 3 options, then 5 options, then 4 options, and 3 options. And did I count that wrong? I clearly can't count. Yeah, so 6. So special has 7 letters in total. Thanks for picking me up on that. So I'll whack that in the calculator. So there are 360 different combinations of 4-letter words using the letters from special that start with a vowel. So that's where we sort of, just an example about restrictions. That one's not too tricky. These next 2 questions are a little bit harder. So let's have a look at this first one. So what we want to sort of recognize is we've got 2 different groups here. We've got 6 boys and 6 girls. And what this question is saying is you're choosing 3 students in total to represent a class in a debate. And we want to see how many teams, at least for part A, has exactly 1 girl. So what you're doing here is you're choosing 1 girl out of 4 because there's 4 girls in the class. If you know you're choosing 3 students in total, that means you're also choosing 2 boys out of a possible 6. So that's what we're doing. 1 girl out of 4, and then 2 boys out of 6. And we're looking at combinations here. So if we sort of isolate these two, let's look at how many combinations do we have when we're choosing 1 girl out of a group of 4. What that's going to be is 4C1. So remember, the number that goes at the top, that is the number, the total amount of people or objects in the group, and 1 is how many you're choosing. So we're choosing 1 girl out of a group of 4. Boys, when you're choosing the boys, you've got 6 boys to choose from, and you're choosing 2. Now, because you're having to do 2 separate groups that you're choosing from, you can think of it as you need to choose 1 girl out of 4 and 2 boys out of 6. And we know that often when we're sort of using the word and, it refers to the multiplication rule. So we're just going to have to multiply these 2 things together. Right. I'll pop that in my calculator and see what we end up with. So 4C1 will be 4 factorial over 3 factorial. 4. It's a little harder doing this in PowerPoint. So 6C2 will be 6 factorial over factorial multiplied by 6 minus 2. And that gives us 15, which, yes, Laura's clearly quicker than me on a calculator. You're right. 4 times 15 is 60. So there are 60 different options. Right, now we're looking at least 2 girls. So the trick with this one is you could be choosing 2 or 3 girls. What we're going to have to do is we're going to do a similar thing to this where we worked out the number of combinations for exactly 1 girl. We're going to do that for exactly 2 girls, or you could have exactly 3 girls. Because, at least 2 girls means you can have 2 or more, and the maximum is 3. So we do a similar sort of calculation here. You've got a group of 4 girls to choose from, and you need to choose exactly 2. And that leaves you with 6 boys to choose from, and you need to choose 1. Now, because it's or, if you remember, or usually refers to you're using the addition rule. You're going to have a certain number of combinations for choosing exactly 2. And because it's or exactly 3, we're going to add up whatever the exactly 3 is. The number of combinations where you're choosing exactly 3, you've got 4 girls to choose from, and you're choosing 3. And then it's going to be 6C0, which will just be 1. So we can just sort of leave it as that. Now, I'm not going to type. Yeah, I might as well. I'll put it in my calculator to see what we actually end up with. So this first one is 36 different combinations. So we have 36 different combinations where we have exactly 2 girls. And we're going to add 4C3. Which is 4. When we add 36 to 4, we have 40. So 40 different combinations where you could have at least 2 girls in this one. Now, if we're looking at probabilities, we're going to look at the 2 previous problems in terms of probabilities. When you have a probability of something happening, the key thing you need to know is that it's found by dividing the number of outcomes in the event by the total possibilities. So a simple example of this is you have the probability of, say, flipping heads with a 2-sided coin is 1/2. Now, the reason for that is, as we know, the number of outcomes where it can actually be heads, there's only one way where that can happen, but there's 2 total possibilities. So we go back to the creating 4-letter words from the word special that start with a vowel. We knew that the total number of words that can start with a vowel was 360. But the total number of 4-letter words just at all that you can create, you've got 7 letters to choose from, and you're choosing 4. So there's 840. So the probability that you would create a word that actually begins with a vowel is the number of words that start with a vowel, 360, divided by the total words you could make. And that turns out to be 3/7, or you could write it as a decimal. I usually tend to go to 2 decimal places, 0.43. Now, coming back to what we just did before, we knew that the number of teams that contain exactly one girl was 60. We worked that out. Let's say we want to find the probability that exactly the team you chose had exactly one girl. So what we want to do is we want to see how many possible teams of 3 are there that you could create. So if you have a class of 6 boys and 4 girls, there's a class of 10 you can choose from, and you're choosing 3 students in total. So 10C3, that is 120. I've got in my calculator. So 10C3 is 120. That's the total number of teams, 3-person teams, we can make. So the probability will be the number of teams that we have with exactly one girl divided by the total number of teams possible. Now, 60 divided by 120, I know off the top of my head, I know that's equal to a half, or we could write it as 0.5. Now, we do the same thing with the number of teams that contain at least 2 girls. Again, the total number of teams that we can make won't change. So if we had no restriction, there's exactly 120 teams we can make. So the probability that a team has at least 2 girls is 40 divided by 120. It ends up being 1/3 or 0.33. So most of the time when you're doing questions involving probabilities, you're going to have some sort of restriction. So in this one, the restriction was the 4-letter words have to start with a vowel. You only had 360 that started with a vowel, but there's 840 total options. And in this case, you had a couple of restrictions involving the number of girls that were in it. Here's a couple examples, just to sort of test out what we've just done. So we've got a 4-digit number with no repetitions is to be formed from the digits 1 to 6. So we've got 6 different digits here, and we're creating a 4-digit number. Firstly, we want to try and find the probability that the number is even. So there's a restriction there that the number has to be even, or that the number is between 3,000 and 3,999. If you're still going, don't stress, but we'll go through how to work these ones out now. So remembering a probability is the first thing you want to try to do is work out the total number of possibilities on your restriction. So we're going to work out the number of numbers you can make that are even, and also work out the total possibilities. And the probability will be this number divided by this number. So how many even numbers can we make? Well, it's got to be a 4-digit number. And if it's going to be even, we know that the last digit has to be an even number. It doesn't matter what the first 3 digits are, but the last digit has to be even. So the number of options we have for the last digit, we could have 2, 4, or 6. So there's 3 options for that last digit. That means if you go back and choose the first digit, there's 5 other options. And we have 4 options for the second digit, and then 3 options for the last digit. And what we want to do is multiply those together. Chuck 5 times 4 times 3 times 3 in your calculator, we get 180 possible even numbers. Now what we're going to do is work out how many total possibilities are there to make a 4-digit number from these 6 digits. Now remember, we've got to ask ourselves, are we going to do combinations or are we going to do permutations? Remember, combinations are when we don't care about what order we're choosing them in. So for example, when we did this example, we were doing combinations because it doesn't really matter whether you choose a boy, then a girl, then a boy. The team's still going to be the same. You're absolutely right. It's going to be permutations because the order actually does matter here. So we're doing, no, I might just do permutations. It's going to be, we've got 6 numbers to choose from. It's going to be 6p4. Six options to choose from, and if we were choosing 4. So 6p4 works out to be, I've got 360 when I put it in my calculator. So the probability will be 180 even numbers out of a total possibility of 360. And that ends up being 1/2 or 0.5. Now, if we actually think about what's going on here, that actually makes sense because half the numbers are probably going to be even and half the numbers are going to be odd. So that answer actually makes sense when we think about it. Now let's think about the probability that the number is between 3,000 and 3,999. So again, we're going to have 4 digits, but this time the restriction is on that first digit. So if it's got to be somewhere between 3,000 and 3,999, that tells us that the first number has to be a 3. There's nothing else it can be. If it's a 2, then it's less than 3,000, and if it's a 4, it's more than 3,999. So we know, there's one option for that first digit. And then the second digit, well, that can be anything. As long as the first digit's a 3, we have 5 options for the second digit, 4 options for the third digit, and 3 options. So we can multiply those together. And that gives us 60. So there's 60 different numbers you can make that sit between 3,000 and 3,999. Now the total possibilities, again, it is the same. It's still going to be 6p4, which we know is 360 from what we did before. So the probability will be 60 options for this restriction we had out of a total possible 360, which simplifies down to 1/6. Again, if you actually think about it, that also makes sense because we've got 6 different options here, and our restriction meant you had to select only one of them for that first digit. So 1/6 of the total possible numbers you can make start with a 3. So again, that kind of makes sense to us.